Okay, can I get somebody to share with the class? What is the name for the smallest common multiple of two numbers? Kalila?
Least common multiple.
The least common multiple, very good. And can somebody tell me what is the least common multiple of 3 and 4? 3 and 4. Is it Jason? Go ahead, Jason. 12, very good. Can somebody tell me the least common multiple of 3? A few people slipped up on this in the morning time. Let's see if you guys got it. Trinity? 20, very good. I had some students say 40. So what were they doing? They were thinking that you just multiply the two numbers. That's not it. Remember, you list the multiples, and here it is for number 2. And then you identify the number in common in that list, and it's the smallest multiple they have in common. Here you see 12, and then for number 3, here we see 20 is the first multiple they have in common. Can I get a volunteer for number 4, 2, and 8? Yes, all the way in the back. Tallulah. 8 is the least common multiple. Very good. So 2, 4, 6, 8. 8, 16, 8, and 8. So the least common multiple is 8. Very good. And then who's got number 5? Yes. 45. Did everybody get 45?
Yes.
Nice. If you didn't get 45, this is a skill you need to know this. You should have known this before you came to this grade, but if you don't know it, you need to make it something urgent that you figure out very soon. Okay? Least common multiple of 9 and 15 is 45. Any questions? Can we move along? Okay, so, this isn't, a lot of our technology has made it so that things are done automatically for us. And so cameras in particular, it used to be that you had to make some adjustments, and you didn't even know right away if your picture turned out. So you can have a roll of film, and you'd take pictures, you'd look through the glass, and you'd take a snapshot, and you would hope when you sent the film off and it came back like a couple weeks later, it used to be a couple weeks, and then they had like what were called 1-hour photos. You'd go to the place, drop off your film, get your film back, and then you'd see when you developed your pictures if your pictures turned out. Well, sometimes your pictures didn't turn out and you just wasted a whole roll of film. So if you think about what you do nowadays where you have your phone and you can see what the picture is and you say, oh, I don't like that, delete. It wasn't that nice before. But you can still make some adjustments to what's called the exposure. And the exposure, if you guys, on your phones, a lot of your phones will let you adjust the exposure. And exposure is essentially when you had the old-fashioned mechanical cameras, it would keep the little lens open to let the light in and basically the picture in, and the picture would kind of burn its image onto the film. It chemically react. The light would chemically react with the film, and then if you kept it open long enough, you kept it open too long, it would overexpose, and what you get is just big white mess. Okay, but you had to make an adjustment depending on how much light there was. So if it's really dark out, you want to leave that lens open long enough so that it can burn in a very, very dimly lit image. But if it's really bright out, you just want to open it really quick. Does that make sense? So we're talking about fractions of a second. And so these settings still exist on modern cameras still to this day. You have these exposure settings. Okay, but that's just kind of the root of it. So let's talk about how that relates to what we're doing today. What you'll learn. To compare and order fractions, the new vocabulary is least common denominator, and that relates to least common multiple. Okay? Why learn this? Camera exposure times are given as a fraction of a second. Knowing how to compare fractions can help you choose the correct exposure times and take better pictures. The exposure times below are listed in order of greatest from greatest to least. That's a typo. If the numerators of two fractions are the same, the fraction with the lesser denominator has the greater value. For example, 1 125th is greater than 1 500th because 1 divided into 125 parts, those parts are going to be greater than 1 divided into 500 parts. Let's think about a pizza, for example. Right, we like food, so I like to bring up food a lot. So if you think about a pizza, you have two pizzas, and they're both the same size pizza, right? Identical, they're the same size pizza. Here they are. I'm going to take one slice from a pizza I cut in half. Okay? And then I'm going to take one slice from a pizza I cut into fourths. Which slice is going to be bigger? Do you guys understand? So if you have parts of a whole, and you take that whole and you slice it into smaller pieces, okay? So basically what they're saying, if the bottom denominator is larger and the numerator is 1, right? So we're comparing the same thing because we're talking about 1 in the numerator. If we're looking at that, then the one that's cut into larger parts, smaller pieces, that slice is going to be less. Does that make sense? Okay, so it's easier to compare fractions that have the same numerator. So let's think about this pizza example another way. Say I have a pizza cut into fourths and a pizza cut into 6 slices. Okay, so do you guys understand what I'm trying to get you to visualize? I have a pizza cut into fourths, so there are 4 slices, and I have a pizza cut into 6 slices. Does that make sense? Okay, so if I take 2 slices from the pizza cut into fourths and 2 slices from the pizza cut into sixths, which am I getting the most pizza from? The fourths, because 2 slices from the fourths give me, really, it's half a pizza, right? And 2 slices from the pizza cut into sixths, that's really going to be what? 1/3, right? Do you guys understand? Yeah. So if the numerators are the same, you can compare them by looking at the denominator. Does that make sense? So I'm just trying to give you some more examples to solidify what this is saying here. Are we good? Okay, now, moving along. That's what this is saying. If the denominators are the same, now if you have a common denominator, and sometimes you have to find a common denominator, that's easy, okay? If the denominators are the same, the numerators show which fraction is greater.
Excuse me, may I have Joshua Major for early dismissal, please? Joshua?
You sure can? He's on his way. If the denominators are the same, the numerators show which fraction is greater. Use the greater than symbol or the less than symbol. Remember the trick I gave you guys with your hands? Which makes the L, that's the less than, which one's the greater than? Yeah. Okay, you can also use models to compare fractions. Any number to the right of any other number on a number line is the greater of the two. So that's kind of what we're talking up here. As we move to the right on the number line, those numbers are greater. So here we have a number line, and we have each mark represents a 6, right? 6, 2, 6, 3, 6, 4, 6, 5, 6. If we have 6 sixths, that's really the same as 1 whole. Do you guys remember that? The numerator the same as the denominator. It's the same as 1 whole. So since 2 6 is to the right, it's greater than, but also since they have the same denominator, that's when you look at the numerators and you say which one's the larger numerator. Well, that's the larger value. Do you guys understand? Okay. So this is a lot of review. Okay. You can also use models, and I had some questions about this earlier. You can also use models to compare fractions. The fraction models show that 7/12 is greater than 3/8. To compare fractions with different denominators, rewrite each with a common denominator. That's what we were talking about earlier. So we have 2 strategies. We said, hey, if the numerators are the same, you have a strategy to compare them. If the denominators are the same, you have a strategy to compare them. But sometimes you have to find a common denominator, okay? So how do we do that? That ties in with our warm-up. The least common denominator of 2 or more fractions is the least common multiple of their denominators, okay? If you could find the least common multiple, then we talk about rewriting equivalent fractions, which is what we covered in lesson 4, okay? And I encourage you to look at that video if that's fuzzy for you. Okay, any questions? Take a look at this model. Now you can see from this model, the top one, I have this rectangle is broken up into 12 parts, right? And 7 of them are shaded. This bottom rectangle, it's the same exact area as the top one, but I broke it up into 8 parts, and there's 3 that are shaded. So you can see visually which fraction is going to be more, right? Okay, the top one, 7/12. Okay, are we good? Any questions at this point? Yes? Okay, I'll go ahead and do that with this. So we have the picture. We can verify it visually. Let's go ahead and find the least common multiple. What is the least common multiple of these two denominators, which is 12 and 8. Well, was that in our warm-up? Let's list the multiples of 8. 8. What's after 8? Okay, after 16? 24. What's after 24? 32. Let's take a look at 12. What's after 12? 24. I already have a common multiple, don't I? So we don't need to continue anymore. So I have 24. That's my common multiple. Now, I need to figure out what is equivalent to the fraction 7/12. Well, 7/12. We know that I can rewrite 12 into a fraction that's got 24 in the denominator. So let's think back to what we did earlier. What times 12 gives me 24? 2. 2, right? So if I multiply 12 times 2, that's going to give me back what? 24. So do you see how I rewrote my denominator? But I can't just do that to the bottom of my fraction. I have to do that to the top of my fraction, too. So since I multiply 12 times 2, I have to multiply 7 times what? 7 times 2 also. So the numerator is going to be what? 14. Okay, so now I want to rewrite my fraction 3/8. And the fraction equivalent to 3/8 that has a denominator of 24, well, what do I multiply by 8 to get me 24? 3. And we see in our list of multiples 8, 16, 24. It's the third multiple, so times 3. And so to get my numerator, I have to multiply 3 times what? 2. No. 3. Wait.
You put 2.
Oh, my bad. I meant to put 3. 8 times 3 is 24. So the numerator, 3, has to be multiplied by what? 3. And so what do I get in the numerator? Did I do that again? Why do I keep doing that? Okay. Times 3. And what's 3 times 3? 9. That is 9. Okay, now guess what? Now we have two fractions that we can compare that are equal to the fractions we were trying to compare, right? So what does that mean? Which one's the larger fraction? Just without the model, with just our fractions that we wrote equivalent fractions for, we see that these two, that 14 is greater. So the one that's greater is going to be 7/12. So 7/12 is greater than 3/8. Okay. This will be in the notes, so. Any questions? All right. Compare these two. Compare them using less than, greater than, equal to. Okay, ladies and gentlemen, we're almost out of time. I want to get this up on the internet. So we're going to go ahead and walk through it. Okay, so the denominators are 4 and 10. The LCM of 4 and 10, if we list those multiples, is 20. So that means the least common denominator is going to be 20. So you guys see what I did? 4 goes into 25 times, so I multiplied both the numerator and denominator by 5. That gave me 15/20. Now for the other fraction, 7/10, since we're trying to get it to a common denominator of 20, okay, 10 times 2 gives me 20, and 7 times 2 gives me 14. Now we can compare the two. Do you see what we just did? Yep. So we rewrote them into equivalent fractions that had a common denominator using the LCD to get the LCD. LCM to get the LCD. Least common multiple to get the LCD. Sorry, a lot of acronyms. Okay. I'm sorry, you guys know I'm getting married this weekend, so my mind's on something else. Okay, shh.
We need pictures, Mr. But you're married right now? Okay, that would take
Okay, shh, quiet, listen up. Take a look. Can you guys help me out? Let's rewrite these really quickly. Common denominator of these two, what's it going to be? 12, yes. So I need to rewrite these. So 4 times what gives you 12? 3. So 3 times 3 is going to be what? 9. And 6 goes into 12 how many times? So 2 times 5 is 10. Good. So which one's greater? It's going to be this way. So that's going to be this way. Okay, common denominator for 6 and 9. Shh, what's the common denominator for 6 and 9? I heard 18. So we got 18 in the denominator. Yep. And how many times will 6 go into 18? So 3 times 1? 3. How many times does 9 go into 18? 2. 2 times 2? 4. Good. So which one's greater? 2 ninths, 4 ninths. 4 eighteenths, so 2 ninths. Okay, so over here, 10 and 8, what's the common denominator? 40. I agree. So we got 40 and 40. How many times 10 go into 40? 4 times 4? 16. 8 goes into 40 how many times? 5. 5 times 3? 15. So which was greater? Boom, boom. Are we good? Okay. Now, listen. They wanted us to order this from least to greatest. Least to greatest. I'm going to leave that up to you guys to do on your own. I'm going to fast forward to the end. How are the least common multiple and least common denominator related? Yes, to least.
You have to find the least common multiple in order to find the denominator.
Least common denominator. Yes, very good. Okay. That's what the book gave us for the answer. The LCM of the denominators of 2 or more fractions is the LCD. Okay, moving right along. Find the least common denominator of each of the fractions. Well, what's the LCD going to be for this fraction? 7 and 9. What's the least common multiple of 7 and 9? 63. Least common multiple of 11 and 5? 55. What about 8 and 3? 24. Let's see the work. So 63 we were right. 55. That is a typo. That should be 5 and 11. Okay. I'm hearing some comments about the last one, 8 and 3. 24. Does it say 8 and 2? What should it say, 8 and 3?
8, 3, 8, 3, 8.
All right, there you go. All right, now let's go ahead and figure out which one's greater, which one's least. Let's walk through it. I think this had more value to it, so I want to skip ahead. 7, 8, what's the LCM of 7, 8? Now, you don't have to find, what is it? 56? Okay, we'll roll with that. As long as we get a common denominator, it'll still give us the right answer. So how many times is 7 going to 56? 8. 8 times 1? 8. 8 goes into 56 how many times? 7 times 3? 21. So which one's greater? Boom, boom. Okay, 12 and 6, that's super easy. I don't need to rewrite that. So let me just go ahead and rewrite this right here. We know it's going to be 12. So how many times 6 go into 12? Twice. 2 times 1? 2. So which one's going to be greater? Boom. All right, last one. Same deal. 5. How many times 5 go into 10? 2 times 3. So which one's going to be greater? Okay, are we good? All right, we had to blaze through that. I apologize.